What up, dudes? We are going to be starting up our lab. I'm actually kind of doing a slight recording for the virtual class. Not because what I usually do is I don't run virtual class while I'm doing lab, but I kind of want to record this to kind of introduce this idea. So let me start off class today. Anyway, let's get this thing started. I want to kind of do a quick advertisement for this thing real quick. We're going to be competing. Myron B. Thompson is going to be competing with 8th graders and 7th graders and 6th graders. Turn off your audio. In fact, if you're actually here, don't log into class. There's no point. All right. Myron B. Thompson is going to be competing in a competition called the Science Olympiad. We're going to be going and competing against other schools like Iolani and Mililani High School and all of that kind of stuff. We're going to be competing against them in this competition. I would like to see if I can put together a team, and I was wondering if you folks are interested in it. Some of the events, I have some of the events, and I'll read them off to you. There's air trajectory, where we're going to basically be firing cannons and landing them. Let's see. Teams will design and construct and calibrate a single device capable of launching projectiles. So we're going to be designing anatomy and physiology. You said you're interested in bisecting things. That might be something good for you. Bioprocesses or bottle rockets. Bridge building competition. Crime busters. Catch the wave. Disease detective. Elastic launch gliders. Dynamic planet. So that has to do with the planet and doing a competition with that. Experimental design, where we're going to design experiments, and we've done a lot of that already, right? Food science, fossils, green generation, meteorology, invasive species, Mission Possible. That's where we design a Rube Goldberg machine. That one's pretty cool. Picture this. Any artist in here?
Yeah, I draw.
You like to draw? Reach for the Stars, the Scrambler. That one sounds really cool. You're going to build competitors must design, build, and test one mechanical device which uses energy from a falling mass to transport an egg along a track as quickly as possible and stop as close to the center of the terminal barrier as without breaking the egg. The Scrambler. Write it, do it competition, and that's basically where you write things down. And also, wind power generation. Yes, question? Not now.
Not now.
Any other questions about Science Olympiad?
I know one.
Yeah.
You know what I can sign up for the Canon one.
You want the Canon one? Okay. So we might need to be selective as to what people do, because there's only 2 people allowed per event. And we're inviting the 8th graders, the 7th graders, and the 6th graders to jump in on this. So I'll let you folks, we'll talk about this later, but I wanted to tell you about it now and also tell you about kind of some of the ideas just to get it in your head. I'll send out an email later on. I know I sent out an email kind of saying, what's your interest, but I didn't tell you what Science Olympiad was. This is kind of what it is. It's a competition, and we compete at the school level, and then we compete at the like at Leeward Community College, where we compete against like Iolani School, and I think Punahou does a really good job sometimes. And I've taken a team from Nanakuli in, and we've actually done really well. Yes, question?
When are we going to do this?
This event, I believe, happens in February for the state competition. And I think that before that, I'm not sure when before that is the smaller competitions. Yes, question?
Are there prizes?
There are prizes. I forgot what they were. I think that one of them, the top prize is actually you get to be flown out to compete in the national stage.
Actually, I know what the prizes.
And a lot of the prizes are like scholarships and that kind of stuff.
What? Scholarships?
All right, question.
Wait, we get scholarships. We don't have scholarships?
I don't know. Don't quote me on that. That might be something that I'm lying about. All right. Yes.
I think we have one with duct tape crafts.
That would be awesome. In fact, I'm sure that you can build a lot of things out of duct tape. All right. So if there's no other questions, let's get started on our lab. Today, here's what we're doing. I want you folks to take a look at your handouts that I gave you. Can I borrow yours?
Yeah.
All right. So we're doing a water filtration competition. I want to get to as much designing and building and actually doing this lab as possible, and I want to do as little talking today as possible. So, because I talk a lot. You guys hear my voice all the time. Why don't you?
I love listening to your voice.
Why don't we actually just get into this lab?
Yeah,
So-
I'm not sure. Need much talking. Need more
Here's what we're gonna be doing. All right.
I explode.
Disaster has struck Hawaii. Maybe like in the form of the book, or even maybe like a hurricane that kind of came.
Ooh, let's make a hurricane.
Yeah, let's say a hurricane has struck Hawaii, and the disaster has struck Hawaii. Our city's water supply has been compromised. Everyone has enough water for 7 days, maybe, but after that, they're kind of in trouble. So there's not enough fresh water available for all the things we need. For example, people, animal, and plants. This lesson / competition allows students to design a water filtration system. Students should learn the complexities of purifying water and therefore the importance of preventing pollution in the first place. Your team will be given a sample of dirty water. That's the dirty water. Do not drink the dirty water. In fact, in this competition, do not drink, do not pretend to lick it, because you might get it on your thing. Some of the water that we will be using later on might have fecal matter in it. You don't want to drink it. Question.
I think you last month. Am I okay?
Your face.
What?
I got a question.
Okay.
I got a question. What's fecal matter again?
Ooh.
Poop. All right. The product that you'll produce will be classified into 3 different categories. Yes, question. Do not drink, exactly. All right. You will have 3 different categories. So here's the different categories. I took the water, I took that dirty water that you have, and I filtered it in my filter that I have. And I categorize it into 3 different categories. So I would say that this one right here is category A. This would be the cleanest. This would be what humans might be able to drink. Don't drink it. This is category B.
I drink that.
It's a little bit brown. I might feed this to my dog.
No.
Well, the dogs have better immune systems.
This is category C.
I wouldn't feed that to my dog.
This has a bunch of junk
I
in the
think
bottom
that
of
would
it.
be plants.
I have no idea what that junk is,
Fecal matter.
and that might be gross. So definitely don't drink it. But don't drink anything in this thing. Does that make sense? All right. So here's the scenario. Okay.
I'm stuck out in the dry desert.
Mr. Dalde's water filtration company, or like let's say disaster has struck, and here's the problem. Let's see. Oh, what? Huh? All right, never mind. All right.
Oh.
Let's say disaster has struck, and so Mr. Dalde called up all of your 7th grade students and said, "Look, the economy, the world needs us, and we need to go in and build these filtration devices." So the government has asked me to make fresh water for you guys, and I'm bringing you folks in as my team. So if you make grade A water, I'll give you $10 per milliliter that you make.
Okay.
All right?
Really?
No, this is
No. After that one, too.
Mr. Dalde is a poor teacher. All right.
Then how'd you get all this stuff into the chemicals?
I had to buy these chemicals myself.
What if we
That's not my 3D printer. All right,
Mine.
moving on. Hey. Pay attention.
Oh, yeah.
All right, I'll give you $2 for a category B thing. So we're going to categorize your things, and then if you make what we call gray water, where maybe I might use this to wash my hands with lots of soap, or maybe I might use this to fill my toilet.
Feed the pigs.
My dad had to.
I would feed the pigs with this.
My dad used to call the water that.
This would be gray water. If you make gray water, I'll give you 25 cents per milliliter. So obviously, this would be the better one to make, right?
I don't know how much. You guys
But I got a question.
Yeah.
Which one do you think is harder to make?
The clean one.
The cleanest one. So now you have to balance this out. All right. So anyone have any questions about the grading system and whatnot?
Nope.
And it's not the grading system like this is your grade in the class, but this is like the categories of water that you can make. You can make A, human drinking, B, feed it to your dog or pigs, C,
Cow.
fill your toilet with it.
Chickens.
Got it? All right.
Cow.
Teams will be broken up into groups of 3 or 4 students. Actually, it's going to be 2 or 3 students in this case. You're going to be broken up into your advisory groups, and then within your advisory groups, I'm breaking those up into smaller groups because I want these things to be a small competition, or like I want you to work closely together. Got it? We will be building a sample filter today. So here's the sample filter that I built, and I actually kind of took out my, I had activated charcoal on the bottom, and we talked about what activated charcoal will do. Let me go back to my video screen. All right, I had activated charcoal at the bottom over here, and I basically used this filter to make these things. I'll let you design your own filter, and here's the thing.
Oh, cool.
We are going to design, today we're going to design like sample filters, and I want to get you folks into building this. What's really exciting about this project is we're going to scale it up at the end. So let's see. Your final project will be conducted in the same groups as your lab today. Okay, all right. So I'm going to basically be having everyone build the same type of filter, but here's the thing. At the Filter Fest, I think that's what they're calling it, at the very end of this year, you're going to compete against each other to build the best filter. And so this is our project that we're doing. So this is kind of the sample, but you folks can build and design better projects later on. Does that make sense?
Yeah,
So at the end of this quarter, in like 5 weeks or something like that, at the end of this month, you folks are going to be coming in and designing bigger projects and better projects than the one we're doing today. Got it? In the same groups you have right now.
Oh.
So that's why I'm having you folks work with each other now. All right? Your final project will be conducted in the same groups. You will design an optimal filters for this project as you will be competing at Filter Fest. We will be running additional tests on the water. So for now, today's test, we're only going to check opacity. We're only going to check how clear it looks. Or we're going to shake it up and see if there's soap inside. Or we're going to see if there's sediment on the bottom. And what is sediment again?
Rocks, tiny pieces of rocks.
Tiny pieces of rocks
Sand.
or whatever is at the
Compacted
bottom
sand.
of this test tube. I don't want to drink that.
Yuck.
Got
That's
it?
so disgusting.
So
That's
we're going to do, but later on when I get the full test in, we're going to test nitrates, nitrites, and fecal matter, and we're actually going to do chemical tests on our water as well. So the filter that you're going to need to design later has to be much better than the one we're building right now. Got it? All right. Materials, procedure. You guys can read this thing. Post-lab questions, pre-lab questions. Anyone have any other questions? Here's what I would do is I'm going to ask that one person in each group make a Google Doc of this thing and then share your Google Doc with your teammates. So just click share and then type in their email addresses into there. And that way one person can do all the recording. There is a part where I ask you to take a picture of the polluted water. I checked it, and I think your Chromebooks can do this. Go to Insert, Image, and you can literally just kind of drag image here. You can take snapshot and allow your camera. And then you can just basically take a picture of it, and then it will input that picture straight into it. All right? So one person has the thing. Don't get the computers wet. Each team needs, I'm only giving you 30 milligrams of, or milliliters of activated charcoal. I had to buy this stuff out of my pocket, and so it's costing me money. So I'm only going to give you, a certain amount. I'd also like it to see if you guys can keep the charcoal separate from the other stuff, because I want to take the charcoal back. I want to keep the charcoal all together. I don't want it to be mixed up with all this junk. Sound good? The charcoal costs like $9 for a pound of it.
So first thing
All right. So maybe when you folks get together as a team, you guys can come up with other ideas. There's one more thing I want to talk about real quick, and then let's just get started on this thing. All right. The last thing I want to talk about is before you leave today, I want you folks to exchange contact information with your lab partners, phone numbers, email addresses, that kind of stuff. I want you to plan to meet up with your teammates at least twice in the within the next 2 weeks. All right. You can decide on where you want to meet. If you want to meet virtually, that would be good. You need to include the off-island students. Got it? If you don't have any in your group, then you don't need to include the off-island students. If you can meet up at like McDonald's or someone's house or Starbucks, that would be good. Or you can always meet. You can always meet at Myron B. Thompson Academy. Got it?
Okay.
This place is always open for you to come in with your team and design this thing. We want you guys to build the best system possible. 2 weeks from now, we're going to have another lab where we're actually going to have other chemicals in where we can test all of this stuff. When we have that in, I want you to have your actual filters, your first prototypes already done. Got it? All right. So I'm going to stay. For those of you who are online and watching this, I apologize that we're not doing the lab with you right now. I'm just kind of recording this to give you all the instructions. I'm going to basically hang up the big blue button and that, but I'm going to answer any questions. Questions?
How do you know?
I think it says it on that thing. It says it on this thing right here. It tells you where they're at. Got it? All right. Any other questions? Comments, concerns, vomits, etc.
Vomit. What?
All right. All right, folks. Have at it.
Observations of wax.
I know your math is not.